the things that are brittle right now where you're like, oh my God, like this is a little too expensive or it's a little too fragile for me to use, like all of that gets better. Like it'll get cheaper and like, things will become less fragile. And then like more complicated things will become possible. Like that is the story of each generation in these models as we've scaled up.
On any given day, Microsoft may be the most valuable company in the world, and arguably no one has been more ambitious, more strategic, or more effective in its AI strategy than Microsoft. The key architect behind that strategy? Kevin Scott, CTO of Microsoft. We've had the pleasure of knowing Kevin for a couple of decades now, dating back to his time at Google when he overlapped with our partner, Bill Korn. Bill will join us today for a very special episode of Training Data. We hope you enjoy. Kevin, thank you for being here on Training Data.
Yeah, glad to be here.
So just to start, I know you've talked about this before, but for our listeners who might not be familiar with your story, how does a kid from rural Virginia end up becoming the CTO of Microsoft?
Who knows? It's certainly not a repeatable plan, I don't think. I don't know. Like it is the thing when I reflect back on my my story is it's just a lot of being at the right place at the right time. So I'm 52 years old. So I was 10, 11, 12 years old when the personal computing revolution started to hit full steam. And so like right at that moment when you're a kid trying to figure out what you're about and like what you're going to latch on to, like I had this like really convenient thing that captured my interest and was a good place for me to ground my curiosity on. And, and I think that's, one of the object lessons in general is if you happen to be interested and like really motivated to learn more and do more with something that is at the same time growing really, really quickly, like you probably are going to end up in a reasonable place. And so, I was interested in computers. I was the first kid in my or the first person in my family. Neither my mom nor my dad went to university, so I was the first one to graduate with a bachelor's degree. Like I majored in computer science and minored in English literature. Like I had this moment when I was trying to decide what I was gonna go do after I got my undergraduate degree, where my two advisors were arguing about whether it should be PhD in computer science or PhD in literature, and I was very seriously considering both. But I was so broke and just so tired of being busted all the time that I picked the pragmatic path. Not that like I still imagine what my life would have been like as a person with a PhD in English literature, and I think it would have been just fine. But like I chose one of my two equal interests, and then for a while I thought I was going to be a computer science professor, and at the last minute, this is where Bill and I intersected. Like I decided I was a compiler optimization and programming languages person through years and years in grad school, and I got almost all the way to the end, and I was like, I don't think I want to be a professor anymore. Like I would work on these things where it was 6 months of effort to write a paper and you make some synthetic benchmark 3% better, and I was like, this doesn't feel to me like the way to have a lot of impact in the world, and like I don't want to do this over and over and over again for the next 25 years of my life. And so I sent my resume cold into Google in 2003, and I got a email from this guy, Craig Neville Manning, who had just gone off to New York to open up Google's first remote engineering office. And like I had an amazing interview at Google. I don't know whether this was on purpose or not, or like I just got luck of the draw, but it seemed like every compiler person who was working at Google was on my interview slate. And I was like, this is amazing. Like all these people like know all of this stuff that I know, and we can have easy conversations. Now, I worked on nothing that was even remotely close to compilers at Google, and I was confused why all of these people were there. But it was a great interview, and I was super stoked, and I joined Google. And Google is yet another one of those things, just like the PC and just like the internet. Like it was a phenomenon that was growing crazy fast with a bunch of smart people working there, and that resulted in this opportunity I had to go join this startup AdMob when it was very early on, like right at this pivotal moment when mobile was taking off, and you needed things in mobile like advertising infrastructure, and I helped build the seminal company, I think, in mobile advertising, and then was back at Google, and then I helped LinkedIn go public, running its engineering and operations team, and then I was at LinkedIn when we got acquired by Microsoft. And so none of that I think you can plan. It's just like a lot of right place at right time, and trying at every point you can to do the most interesting thing you can do on the thing that's growing really fast.
When you talk about your personal history, Kevin, I guess, the focus nowadays is on AI, machine learning. A lot of the practitioners are people with PhDs. How do you think about sort of practical teams for AI, since you're obviously doing a lot of that work at Microsoft and involved with partnerships with OpenAI and others?
Yeah, I mean, I think if you are building the really complicated platform pieces of AI, so like the big distributed systems for training and inference, the big like networking and silicon and system software components, or the algorithms that you're using to do training and inference, I think a PhD is super helpful. Like there's just a huge amount of prior knowledge that you need to have in order to jump into the problem space and be able to like go quickly, and like you need to be clever, but like PhD is I know you have a PhD, Bill, and are far cleverer than I am, but like usually folks with PhDs are clever, but like they're not the only people in the universe who are clever. So like I think it's mostly helpful in the sense that you've gone through like a pretty rigorous training regimen where you get a whole bunch of prior art stuffed into your skull, and like you demonstrably can do a very complicated project. The PhD projects look kind of like AI platform systems projects, except the AI platform and systems projects are lots and lots of people working together, whereas when you're getting your PhD, you often are like working in relative isolation on like your particular thing. So like that's the one of the things people have to learn is like how to get yourself docked into a group and to be able to collaborate effectively with a bunch of other people like yourself. So useful, but there's so much else in AI that needs to be done other than building the platform. And for those things, PhD is helpful, but certainly not necessary. Like figuring out how do I apply this to education? How do I apply this to healthcare? How do I build developer tools around this? How do I do all of the million things that happen when new platforms emerge, that you sort of complete the whole platform into like a portfolio of products and a portfolio of middleware and a portfolio of like all of the other stuff you need.
Well, speaking of which, Microsoft seems like it has about the most sort of far-reaching or ambitious AI strategy of anybody out there. Can you just kind of say in a couple words, what is the AI strategy for Microsoft? And then just for fun, if you're going to grade yourselves, what have you done particularly well? What have you done maybe not as well as you could have?
Yeah, so, I mean, we've been sort of talking about this strategy. Microsoft is a platform company. Like, we, I think, have participated or, like, helped drive a handful of the big platform waves in computing. Like, we were certainly one of the pillar companies in the personal computing revolution. Like, we had an important part to play in the internet revolution, although I think that one was a far more diversely contributed to revolution than personal computing. We kind of missed the mobile computing revolution. But like each one of those things, like we have thought about how do you go build a technology platform for this particular era of technology that allows other people to go build on top of that platform to make useful things for other people. And so that is our AI strategy. It is like, how do you, from frontier models to small language models to like highly optimized inference infrastructure, like hyperscale on both training and inference, like economies of scale, like making the entire platform more accessible because it's cheaper and more powerful with every turn of the crank, and like all of the developer tools and safety infrastructure and testing and everything that has to be there in order to have robustly built AI applications. Like, go build that, and like listen to developers and listen to people building AI as intently as you possibly can, so that you are filling in all of the gaps that you can for them as they are encountering problems deploying this technology to users. So that is our strategy. And so, yeah, I think we're doing a reasonable job of it. I don't know, like, I hate to grade myself. It seems a little bit disingenuous, right?
Highlights and lowlights.
Well, but maybe before I do that, like, let me describe something about my own psychology. So I am an engineer, and I think most engineers are short-term pessimists, long-term optimists. And so the short-term pessimism is like, you come in every day and you're like, oh my God, this is like a bag of crap. Like, I just don't like any of this, and like everything's broken, and like I got so much stuff to fix, and I'm so frustrated. But you work on all of those things anyway because you're optimistic that all of the problems can be fixed and that they're going to be worth fixing at the end of the day. And so, yeah, I mean, there's a bunch of stuff that I think we're doing really well. Like, I think we have absolutely, along with OpenAI, made very powerful AI dramatically more accessible than it otherwise would have been to a larger group of people. I think because of that work that we've been doing alongside OpenAI, we have we're just seeing lots and lots of customers who otherwise wouldn't be building powerful AI applications. And so, like, I feel like we're doing a good job in the way that we're partnering. I think we're doing a good job in like having a really particular point of view, and it's not an immutable point of view, but like it's a point of view about like what an AI platform ought to look like, and we're trying to like make it as complete as we can. Lowlights is, I think we were a little bit late to like some of the basic AI stuff, so it wasn't that we were not investing in AI at all. And like, you can sort of look at some of the work that Microsoft Research had done over the years, and like MSR was an early AI leader. And I think Bill knows this just as well as I did, just from his time at Google, and where we overlapped for a number of years. But maybe most of the really important advancements in AI over the past 20 years have been a function of some kind of scale. And it's usually you got data scale and compute scale in combination let you do things that weren't possible at lower scale points. And at some point, like that scaling of data and compute is so exponential that you get past the point where you can have fragmented bets, where you can literally, it just becomes economically impossible to bet on 10 different things that are all exponentially scaling or have the ambition or the need to exponentially scale simultaneously. And so I think one of the things that we were a little bit late to is like we didn't put all of our eggs into the right basket soon enough. Like we were spending a lot on AI, but it was fragmented across a whole bunch of different things. And because we didn't want to hurt any of the feelings of smart people or whatever, right? Like I don't even know what the diagnosis was because a lot of that was before I was at Microsoft. We just weren't as quick as we should have been at saying, no, scale is what matters, and like here's how we're going to focus our investments on scale in a principled way.
When did you get religion that scale is what matters? Was there a particular event or a moment that really crystallized that for you?
Yeah, I mean, I've been at Microsoft for about 7.5 years now, and my when I became CTO, my job was like take a scan left to right across both Microsoft and the entire industry and try to see where we just had holes in execution where like we were not doing things at that point in time, which was I guess 2017 early, where, all right, like what are we not doing today that we're going to deeply regret in 2019 or 2020? So like 2-3 years out. And like the biggest thing on the list was like, our rate of progress on AI was not fast enough. So I'd say mid 2017, like I had religion that was going to be a big part of my job, was like helping us figure out what the strategy was going to be. And then in 2018, like if anything, the publication of the BERT paper from Google was like a real crystallization of that belief. So like everything that I had that was in my analysis, I was like, this is as fine an example as anything of like why we have to really, really accelerate on getting more serious here. And so like, very shortly after that, like I restructured a whole bunch of stuff inside of Microsoft to get us more focused on AI. And then about a year later, we did that first deal with OpenAI. We have been accelerating our investments and like trying to get more focused, more crisp, more purposeful since then.
When you were very early to appreciating the potential of OpenAI, what did you see in them at that time when that first partnership was struck?
Well, we had like, or at least I had this like real belief that what was happening with these models as they scaled, as they actually became a basis for building a platform, that like the big shift that was happening is it wasn't just, I ran one of these teams at Google where you had a pool of data and a bunch of machines and an algorithm, and you were like training a model, and like the model was for a specific thing. Like in the case of the things I was doing at Google, it was like click-through rate prediction for advertising and, like a handful of other things. And like just outrageously effective, right? But most of the work before GPT was about those sort of narrow use cases. Like you were purpose building models for narrow things, and it was just tough to scale. Like you'd invest a bunch of compute and like you couldn't amortize the cost of the compute across anything more than just the narrow thing that you were building the model for, and you had to have a lot of expertise that you know, if you wanted to replicate all of this, it's like you had to have different data and like different, you know, AI PhDs and, you know, different processes every time you wanted to go build AI into an application. And what was happening was like, yeah, you had these big large language models that were useful for lots of different things. So you didn't have to, you know, have a separate model for machine translation and sentiment analysis and, you know, like all of the different text things that you were doing. And I was like, okay, this is extraordinary. And like they were also becoming more platform-like as a function of scale. So transfer learning was working better as things scaled up. And yeah, and this is still the general pattern. So like everything that we understand that large language models can do, plus or minus, like will get better when you get to the next scale point. And on top of that, they will become slightly or maybe dramatically more general in the sense that their capability set broadens. And OpenAI had that same belief, and they also had like a very principled analysis of like how those platform characteristics emerged over time as a function of scale. And a bunch of experimental validation that said that their forecasts were right. And so like it just, you know, you sort of like look at what the forecast says and you're like, this is how much money it costs to run the experiment to see if you're going to be on forecast for the next turn of the crank. And like, you know, it felt like a big number at the time, like it was $1 billion. But like relative to what was happening, it just wasn't a large amount of money. And then GPT-3 was on forecast and GPT-4 was on so like it just was like finding a partner that had the same platform belief that you did and like a track record of, you know, being able to execute through these scale points. Like it was, like I've done a bunch of things before that I have way more reservation about in the past, like just in terms of investments. Like this one didn't, you know, like there was a bunch of people who didn't agree with me, but like I had pretty high conviction.
You touch on investment. I guess, you know, there's a lot of trade publications now speculating about the cost of doing training and so forth, and you know, rumors of billions and billions of dollars being spent and so forth. And I guess based on my own background, I think training's going to get dwarfed by inference here pretty soon. How do you see the?
Should hope so.
Well, yeah. Otherwise, we're building models that nobody knows what to do with. That might not be a great investment. But how do you see kind of computing landscape evolving, and where's it going? You know, I think people are joking that all the money's going to Nvidia at the moment. So.
Well, look, I think Nvidia's doing a good job. So like the two interesting things that are happening with these models, just in terms of the efficiency of the scale up, is each hardware generation's better price performance wise, usually by an extent greater than Moore's law used to work for general purpose computing. So, A100 was about, 3.5 times better price performance than V100, H100, like not quite that much, but, close. On paper, the next generation looks very good as well. And so, like, you've got hardware for a variety of reasons, part of it's process technology, but part of its architecture, and like a lot of it is like being able to leverage narrower word size in the computation. So like, instead of needing 64-bit arithmetic, like you're doing arithmetic with much less precision right now. And so like that, there's just an embarrassing amount of parallelism there. Then like we're getting better and better at extracting that architecturally in the hardware. And, there's a bunch of innovative stuff happening with networking as well. Like we're well past the point for the frontier models, at least, where you can do anything interesting on a single GPU. So for years and years now, like both training and inference have been multi-GPU, multi-compute node problems. And so like there's a bunch of innovation happening on the network side as well, which allows you to strap all of the compute together, like at the chassis level, the rack level, the row level, data center level more effectively, which is great because, for the nerds listening, like we haven't had effective power scaling or Dennard scaling since 2012 or so. So yeah, we're getting more transistors, but like they are not, they're not getting cooler. And like we have a lot of density issues just with power dissipation that we have to go deal with.
Do you see inferences driving different data center architecture?
Yeah, I mean, look, we already architect our training environments and our inference environments differently. They just need different things. And like I think, all the way down to, silicon and like through the network hierarchy, you need different things for inference. And like inference is kind of easier than training. Like training, the way that we're doing it now is like we go build big environments that take a few years to build. And with inference, like if somebody came along with a better silicon architecture or a better network architecture, like a better cooling technology, like it's a much easier experiment to go run. You just go swap some racks out. I mean, like my data center people would yell at me, like it's not quite that easy, but it is easier than like having to go like do a big capital project like a training environment looks like. And so like I intuitively you would think that is going to result in more diversity in the inferencing environment and more competition and more like a faster rate of improvement. Like that's, and like on the software side, that's certainly what we see. Like the inference stack, just because it's such a large fraction of the overall compute footprint, and it's constrained because we have more demand than supply at the moment. Like you just have very, very powerful incentives to go optimize the software stack to squeeze more performance out of it.
Do you think we'll be in an environment anytime soon where that demand-supply balance changes? Not necessarily at Microsoft, but it feels like we're seeing that at the market level as well.
Yeah, I don't know. I mean, if we continue to see the platform continue to expand capability-wise, and it just becomes more useful, like I think demand increases, if anything. Now, the shape of the demand is probably going to move around. Like I think you're already seeing a little bit of that. Building a frontier model is like a very, very resource intensive thing, and as long as people are like building frontier models and making them accessible, and like maybe they're not accessible quite the way that people want, like they're only API accessible, and like there isn't an open source thing you can go instantiate and muck around with, but like it's way more accessible than it was 6 or 7 years ago, where like the only way to access some of this stuff is you had to go work for like two or three tech companies, and it's, so anyway, like but I think you do have to ask yourself, and somebody else should do the asking, right? Because I'm like all kinds of biased, right? But like I don't know how many frontier models you actually need, if they're all roughly speaking in the same tier of capability. That's an awful lot of money to spend for things that are roughly equivalent. It's sort of like, if you're starting a company right now and you believe that you have to build your very own frontier model in order to go deliver an application to someone, that's almost the same thing as saying, like, I got to go build my own smartphone hardware and operating system in order to deliver this mobile app. Like, maybe you need it, but like probably you don't. And so, I mean, to Bill's point, like, I think the thing that makes sense, for the market is like you're going to want to see lots of people doing lots of inference, because that means you've got lots of products that have found product market fit, and those things are scaling. But like lots of speculative dollars flowing into infrastructure R&D, like, probably ends the same way that many speculative infrastructure booms have ended.
On this, on the scaling front, Microsoft published a paper some time ago pointing out that the quality of training data is maybe at least as important as volume. And I think one of the speculations you see now in the industry is that we're running out of sources of high quality training data, and you're reading at least some articles claiming that various partnerships are being struck to get access to training data, and it might be behind paywalls and so forth. How do you see that evolving? Because it feels like we have more and more computation, but we may not have more and more training data.
Yeah, I mean, I think that was almost inevitable. It is, in my opinion, a good thing that quality of data matters more than quantity of data, because it gives you an economic framework to go do the partnerships that you need to go do to make sure that you're feeding your AI training algorithm a curriculum that is going to result in smarter models. And like, honestly, like, not wasting a whole bunch of compute feeding it a bunch of things that are not. And I think one of the, from an infrastructure perspective, one of the things people have been very confused about is, like, a large language model is not a database. It's not a repository of facts. It's like important for it to, quote unquote, know some factual things. But it is like the world's crappiest database, honestly, like, if you need it to be your retrieval engine. And so, like, you just shouldn't think about it as like, hey, I got this thing and like it has to have everything baked into it, like into the model weights themselves, so that you can recall a bunch of stuff. Because, like, as you've seen, like the recall is imprecise in the same way that human recall is imprecise. So they're just much more efficient ways to do recall. So look, I think the way that we see things developing is, like, you have data that is valuable for training models, and then you have data that you need to have access to for an application in order for the model to reason over. And, like, those are two different things, and I think they're probably two different business models around those things. So, and like, at the end of the day, this is about business models, right? Like, people who produce data want to be compensated for use of that data. And so we have all of this data sitting inside of search engines right now, like, not in randomized weights, but like quite explicitly it's like sitting in indices and Bing and Google and whatnot, just waiting to be retrieved. And, like, plus or minus, everybody's okay with that because there's a business model there that makes sense. So you enter a query and, like, you're either sending traffic or like there's SEO and, like, advertising and, like, a whole bunch of, like, business model that surrounds that. I think we'll figure out a business model for that referral data, so that, like, when an agent or an AI application needs to retrieve some information from someone so that it can reason over it and give the user an answer, like we'll figure out the business model for that. Like it'll either be subscription rev share, it'll be licensing, it'll be like some new flavor of advertising. I was just telling someone the other day, like if I was in my 20s right now, like, for all of your entrepreneur, like somebody ought to be out right now figuring out what the new ad unit is for agents and like just building the company, because like it will have the same characteristics and qualities as previous ad units. Like you have people with information and products and services who are going to want to get to the attention of someone who might want those data and products and services, and like quality is going to matter, and relevance is going to matter, and a bunch of other things. And I would be shocked if there isn't a auction model for that's going to be the right way to value everything. And maybe there's referrals, and like referrals will have some economic value. I think for training it's just a little bit different, because it's very, very hard when you're building that model to at the time that you're doing the building to really be able to ascribe a monetary value to a particular token of input.
Yeah.
Just because its contribution to the model, like the same way that a word from Moby Dick has like a very diffuse contribution to like your own human intelligence, even though you definitely read it at some point in your career or your life, like how valuable that is to like forming Bill Corrin or Kevin Scott's useful intelligence. Like who knows?
Speaking of which, this one of the things that we hear a lot of times is the value function is in some ways the bottleneck to broader reasoning capabilities. It's easy enough to construct a value function when you're playing a game with a known winner and loser like Go or chess or poker or diplomacy, but it becomes a lot harder to construct the value function when you're going into broader domains, and it's things like assigning the value of Moby Dick to Kevin Scott's life, that sort of thing. Are there practical solutions to this? Are there practical implications to this? I guess the broader question would be, where do you see the overall field of reasoning in LLMs going?
Well, look, I think people are trying to get at this. So you've got a bunch of benchmarks like GPQA and MMLU, and like we're just sort of rolling through a bunch of benchmarking paradigms to like try to come up with scores of performance for these models, like whether it's reasoning capability or I think one of the interesting things we've seen over the past handful of years is like we just are very quickly saturating these benchmarks, like where you like one emerges and then within a model generation, like you'll completely or like get very close to saturating the particular benchmark, and then you got to go find something else to help be your guiding light. But like let's just sort of assume that like you'll have some interesting benchmarks that are correlated with the reasoning capabilities you want models to have. Then the question, it's just an expensive experiment to run. Like you can run an experiment where it's like, okay, like I'm going to train a model like with this information in it or out, and like does it get better or worse at performance on these reasoning benchmarks? And like I think all of us have done different versions of those experiments. Like they're just extraordinarily expensive to run at the most granular scale you can imagine running them. Yeah. Part of that paper that Bill referenced, like textbooks are all you need, is like it's not the full story, but it's like part of a story that is like just sort of evaluating like token contribution quality to model performance. So I think it's and everybody's got every incentive in the world right now to try to figure out like what that is, if for no other reason than you like in a world where you're synthesizing data, you're literally spending compute to generate synthetic tokens for training. you really want to make sure that the tokens that you're generating are actually useful or not.
Where do you think the models are at the moment? I think Microsoft has introduced a whole bunch of copilots to try to help end users with your products and so forth. On the other hand, I see lots and lots of companies trying to build agents that can be kind of autonomous actors now. That's a wide spectrum of kind of expected performance of what the models can do. Where do you think we are? Where do you think we'll be in a couple of years?
Well, yeah, so I think that's a super good question, and there's even a philosophical thing there about what it is we should want.
Well, there is the specter of everybody's job getting replaced, right? So
yeah, somebody look. We chose the name Copilot for the things that we were doing relatively deliberately because we want to, at the very least, encourage everyone who's building these things inside of Microsoft to think about how can I help augment someone who's doing some form of cognitive work. So like we want to build, assistive, not substitutive tech. And the good news is also easier to think about how to go from, sort of rough frontier model capability to useful tool when you're narrowing it down to a domain. And so, like, I think that's been a reasonable deployment path. And, like, we've got a handful of our co-pilots that have real market traction right now and are, like, in daily use by, like, a lot of people doing, real non-trivial cognitive work. And I think that will expand over time.
What are some examples of co-pilots that have really, like, hit the bullseye already versus maybe co-pilots where the technology is not quite ready in terms of like jobs to be done?
Yeah, like I think GitHub Copilot is like probably the thing we've talked most about, and like there's the most public conversation around. Like it's been a hit. It is genuinely useful. We've got some other co-pilots that are like that are that are super useful. But I think the thing that Bill was getting at, like the more general the co-pilot is, like the harder it is to have it actually take very high precision action on your behalf autonomously. Particularly if, it's doing something where it's representing you, where, there are stakes and, consequences and accountability back to you if this agent makes a mistake. And we're trying to be very deliberate there because I think one of the things that you don't want to do is introduce a thing that's going to make a whole bunch of these sort of errors where the user's first reaction is like, this doesn't work, and like I'm not going to try it again for a good long while. So we'd rather have it be very good before we introduce it. Which again, means you're sort of optimizing for use cases, not for like super super broad things. I mean, there's a good, like we did a partnership recently with Devin, which I think is another one of these like very interesting like use case specific things where it's like frontier model plus a whole bunch of other stuff that is like optimized for like giving humans high quality recommendations for actions that they can take, and then when you click accept on the action, like you have reasonably high confidence that it's going to work, and you haven't made another set of problems for yourself. And so, like, I'm guessing too, you all see this in your portfolio companies. Like, there seem to be a bunch of companies out there right now that are like doing exactly this, and that it's useful and working.
Well, it's interesting because one of the things that we hear fairly consistently from the companies that are further on in their AI journey. Everybody kind of starts in the same way where they start playing with OpenAI and then maybe they start using some of the other proprietary foundation models and then they incorporate some open source models and maybe they have some of their own stuff. There's a vector database in there somewhere.
Yep.
From an architectural standpoint, it feels like people tend to go on a not quite the same journey, but journeys that sort of rhyme. But then what we hear from them when they're 12 or 18 months down the road is there's kind of this massive 80-20 rule at play, and maybe it's a 98-2 rule, but you can automate most of a task pretty quickly and pretty effectively, but getting it to the point where it's actually end to end running autonomously in a way that is compelling and consistent enough that you can actually trust it, kind of that last mile, that last couple percent that makes you really trust it. Yeah, it seems like that's been pretty elusive for a lot of tasks. And so one of the things that we're really curious about is, okay, well, when do the foundation models themselves, get good enough to knock out that last 2%? Or is that a domain-specific thing? And that's really the job of the software vendor who lives on top of the platform to figure out that last 2%.
Look, I think it's going to be both for a while. Like the two things that I think you can trust. Yeah, I know you guys are probably going to ask this question at some point, but like we're despite what other people think, we're not at diminishing marginal returns on scale up. And like I try to help people understand, like, there is an exponential here, and like the unfortunate thing is you only get to sample it every couple of years because it just takes a while to build supercomputers and then to train models on top of them. And so the next sample is coming. And like I can't tell you when, and I can't predict exactly how good it's going to be, but it will almost certainly be better at like the things that are brittle right now, where you're like, oh my god, like this is a little too expensive or it's a little too fragile for me to use. Like all of that gets better. Like it'll get cheaper, and like things will become less fragile. And then like more complicated things will become possible. Like that is the story of each generation of these models as we've scaled up. And so like, we even think about this inside of Microsoft, and like one of the category errors that our own developers who are building these AI products can make is like get too convinced that the only way to solve my problem is like I have to go take the current frontier and supplement it with a whole bunch of things. But which you do have to do, but like you want to be very careful architecturally when you're doing that it doesn't prevent you from taking the next sample when it arrives. So you just want to architect these applications where when the new goodness comes, you can go plug it in, and like you'll have to go optimize that as well. Like I think that's just sort of the grind that we're on. But like you just like the thing that was killing us internally is I would have teams inside of the company who would look at a frontier model and say, oh my god, there's no way that we can ever deploy a product on top of this because like this is fragile and this is too expensive, and so like please give me like giant pools of GPUs and like let me go spin up a big team doing like a very tailored version of this, and like we're going to build a specific model, and like and yeah, they would go off and like spend a whole bunch of money, and like the thing would be a little bit better cost-wise at the same level of performance as the current frontier. And then the frontier would snap to the new point, and it would be just doomed. And so, like, you just architecturally don't want to get trapped by that, I don't think. I mean, like, that'd be my advice I give to everyone, is, like, just give yourself the flexibility to snap to the new, to the new frontier when it emerges. Yeah. And like that lets you preserve all of your skepticism. You can believe believe all you want that the new frontier is not coming. Like go, read your favorite Twitter troll that says it's all over and a sham, but just give yourself the option that maybe what's been happening for 6 years now is going to continue.
Well, hearing that we are not at diminishing returns to scale, I'm going to count that as good news. And so let's stay on the theme of good news. I know that you're short-term pessimist, long-term optimist. Can you give us some of the optimistic point of view for where we're heading in this world of AI? Like, what are some of the things that you're most excited to see in the world in 5 or 10 or 15 years, or whatever you count as a longer term horizon?
Well, look, I think the thing that everybody ought to like spend some time thinking about is where are the gnarliest zero-sum problems that we have in society? Like where are the things where like we just are fighting with one another, or like we are immiserating people because whatever it is that people need, there doesn't appear to be enough of it. And I think for a good number of those things, like what you have to have to turn them into non-zero sum games, to create abundance and to relax some of these constraints, is you have to have technological breakthroughs. It's like the only thing that reliably that's ever turned zero sum to non-zero sum in human history. Is like some tech has to come along that like lets us have more. And like whenever tech comes along and like creates more, it doesn't mean that the more gets equitably and uniformly distributed. And like I think there are real conversations to go have about that. But like what you do want is the more, and you want it to be directed at things where like we're just having a tough time right now. I'll tell this story that I've told a couple of other times recently, but my mom, like I grew up in rural Central Virginia. My mom's 74 years old, and like she's suffered from this thyroid condition called Graves' disease for 26 years. And so when you have Graves' disease, your thyroid is hyperactive. You're generating too much thyroid hormone, and so they go in and like irradiate your thyroid gland to reduce its activity level, and then you take hormone replacement therapy to like upregulate your hormones for the rest of your life. And so she was having some blood pressure issues, and her doctor dorked around with her dosage of this hormone medicine, and then like she just had like some serious health issues as a consequence of that that landed her in the ER in rural Central Virginia like 6 times, like in a pretty short number of weeks. And the interesting thing there was the first time she went to the ER, like she was presenting all of these cardiac symptoms, and it was pretty clear they hadn't even read her chart. Like it hadn't registered on them that she had Graves' disease, and like the thing that they needed to do was like go order a TSH panel to see what her thyroid hormone levels were. Like if they'd done that right away, like they would have said, okay, like we got to go, adjust your medicine. And like I'm not even ascribing ill intent. Like this is a healthcare system that is egregiously overburdened. Like this is not a place where like you've got this influx of talent like coming into this part of the country, and like it's a lovely part of the country. Like I like love it. So like I'm not criticizing anything. It's just they have an aging population, and they don't have enough like young people coming in to be things like doctors to like help this healthcare system keep up with all of the challenges that they have. If some of those doctors had access to GPT-4 and like it was an approved product use, all they would have needed to do was like put the symptoms that she was presenting in and her medical record, and it would have said, hey, she needs a TSH test. And if you would put the TSH test result in, the recommendation it would have was like, look at the dosage of her hormone replacement therapy that she's on. And like if like this isn't theoretical, like I did this, like it could have helped alleviate a massive amount of her suffering right now. And like I think the only reason like that she got out of this tough situation that she was in was I had to intervene. Like I've sent her to a specialist that was 400 miles away that she couldn't have gotten into without special and like it's it's ridiculous. Like, yeah, there are so many 74-year-old old Southern ladies or old Midwestern ladies or like folks who are going through similar sorts of things who do not have someone who's going to go in and intervene on their behalf, who are suffering unnecessarily because we're not even deploying the technology that we've got right now. And like, it's just going to get better. And so like, that's the thing that I'm excited about. It's like, let's go give kids a leg up in education. Let's go fix some of these crazy problems we've got in a healthcare system that is just, absent technological intervention, is just going to get more strained over time. Let's equip our scientists with better tools so that they can, find better carbon capture catalysts so that, like we can design safer modes of transportation so we can more quickly get to a, like post-carbon economy. Like, it's just so many things we can go do with this stuff. Like, I'm super, super optimistic about it. And so, like, it just kills me, like, what we don't want to do is get distracted on, like, things that are just, effectively noise in the ecosystem right now. And, we're getting so sideways sometimes with, like this model like said something that hurt my feelings, or and I don't want to dismiss, like, people's feelings matter, and like, I'm not trying to be a jerk here, but I do want to make sure that as we're thinking about how we develop and deploy the technology, that we are always remembering like what the cost of not deploying the good is, because that is a high cost.
Mm-hmm.
Very well put.
Yeah, very well said. Probably a good note to end on, I think.
Well, we have one other question that we like to ask people, and it's a quick one. So I'm going to ask you this one: who do you admire most in the world of AI?
I was thinking about this. So I think it's Ray Solomonoff, who was one of the folks who was at that Dartmouth workshop in the 50s, where Marvin Minsky and Simon and like a whole bunch of folks convened that summer, and like they were all interested in machine intelligence, and they coined the term artificial intelligence at that workshop. And like the reason that Solomonoff is so interesting, and like not many people I think know who he is outside of computer science, is like he was the one from the very beginning who was pushing on this whole notion that probabilistic methods were going to be very important for the development of AI. And when I was in grad school in the 90s, the prevailing academic theories about how we were going to get to AI were all about like, okay, well, like there's some magic, minimalist calculus about human intelligence, and like we've just got to figure it out, and it's got to be, rule-based systems and ontologies and, symbolic reasoning and like a bunch of like stuff where, we do in physics, we were going to have to like, divine, the inherent simplicity in the system, like figure out what the rules are. And as soon as we understood the rules, like we'd be able to make software emulate human intelligence. And Solomonoff is like, no, like this is just intelligence is an extraordinarily complicated phenomenon. And like the only way that we're ever going to really get there is modeling it with probabilistic methods. And he was right. And like he was judged wrong for a very long time. And so I really admire his contrariness, all the way back in the 1950s, and like he stuck with his beliefs his entire career. And I don't know whether Ray actually lived to see how right he actually was.
That's a great answer and a great story. Thank you, Kevin.
Yep, you're very welcome.
Thank you.